let's take a look at some special theorems dealing with expected values. All right, so the first theorem that we have is if we have a constant, we just want to know what is the expected value of a constant. That is just the constant. If we take a constant times a function of the random variables y1 and y2, then if we want the expected value of a constant times that function, we can bring that constant out in front. And so it is that constant times the expected value of that function. And if we want to know what is the expected value of a sum of functions, it is the sum of the expected values. Right, so the expected value of the sum is the sum of the expected values. All right, so let's take a look at an example, see how we might put these theorems to use. So gasoline is to be stocked in a bulk tank once at the beginning of each week and then sold to individual customers. Y1 is the proportion of the capacity of the bulk tank that is available after the tank is stocked at the beginning of the week. So that value of Y1 is going to vary from week to week. Y2 is the proportion of the capacity that is sold during the week. So our value of Y2 can't be more than the proportion that's available. Right? So we want to know, so that value, that difference between Y1 and Y2, that's going to be the proportion of the amount of gasoline that's remaining at the end of the week. Right? So at the beginning of the week, it was stocked with Y1. Over the course of the week, we sold Y2, and so that difference is whatever's left. And so we want to know how much do we expect to have left over at the end of the week. So that value, the expected value of Y1 minus Y2, using our rules from above, we could split this up as the expected value of Y1 minus the expected value of Y2. So we can find each of those expected values separately, and then after we've found those expected values, we can put it together and find out what is the expected value of the difference. So the expected value of Y1, when we roll through this, we have an integral, so we're going to be integrating from negative infinity to infinity. So let's, on the inside, integrate with respect to Y2 first, and then with respect to Y1. So we have Y1, 3, Y1. So here, our limits of integration for Y2, that Y2 is going to be limited by 0 and Y1. So it's going to integrate from 0 to Y1. Our limits of integration for Y1 then are going to be 0 to 1. It's already taken into account kind of that limiting factor of Y2 on the upper end or on the lower end. So when we integrate this with respect to Y2 first, we get Y1 squared, Y2 evaluated from 0 to Y1. So this is an integral from 0 to 1. 3y1 now cubed. When we integrate this now with respect to y1, we add 1 to our power, divide by the new power. We're integrating this or evaluating this from 0 to 1. So we get 3/4 is our expected value for y1. Our expected value for y2. Our expected value for y2 is an integral from 0 to 1, integral from 0 to y1. Here we have y2 times 3y1 dy2 dy1. And so when we integrate with respect to y2 first, we have 3y1 y2 squared. So we added 1 to the power divided by the new power. And so we have an integral from 0 to 1. Now 3y1 cubed over 2. We're integrating with respect to y1 now. We integrate that with respect to y1. We add 1 to the power, divide by the new power. And this is going to be integrated from 0 to, evaluated from 0 to 4. So we get 3/8. And so the expected value of the difference between these two that is ultimately just going to be 3/4 minus the 3/8. And so that will ultimately give us 3/8 here as well. All right, beautiful. We will talk to you guys next time.